G'day again, we're up to question 11. Now question 11 is usually a simpler form or a simpler set of questions for the whole HSC. So each of these you should be able to do. So let's go. Question A, simplify 4x minus 8 minus 6x. This is basic algebra, you should be able to do this. The negative just reverses the sign of everything inside the brackets, so we get 4x minus 8 plus 6x. Now we're going to join together the common terms. So the only common terms are the 4x and 6x. The 8, there's no other single numbers on their own. So 4 plus 6 is 10. 10x minus 8, and you're done. Pretty straightforward. You should be fine. Factorise 3x squared minus 27. Just be careful when you're looking at this that you don't misconstrue that for a cubic, because you've got three cubes there. So you might accidentally start expanding it into the cubic expansion. But there's only one thing that goes into both of those, and that's 3. So let's take that out to start with. Now what you've got in here is the difference of two squares. That's x squared minus 3 squared. And you should recognise that you can expand that into the difference of two squares. And you're done. Okay, 11C is just express this number with a rational denominator. Pretty easy. You should know how to rationalise the denominator. You're just multiplying by 1 by using the same number top and bottom to create the difference of two squares. So we're going to use the opposite of this, 2 minus root 7 over 2 minus root 7. This is the difference of two squares on the bottom. And on the top, you're just doing one at a time. So 8 times 2 is 16, and 8 times root 7 is 8 root 7. Clean up the bottom, you get negative 3. Don't leave a negative on the bottom for your HSC answer. So move that negative up the top and switch both of those around. So you should get and that's it. You can't simplify that any further, because if that was a 4 it would be great, but it's not. That's it. Okay, 11D. So again, another straightforward question that you should be able to do. Limiting sum, you should remember your formula is A over 1 minus R, and you're just looking for A and R in there. So A is the first term, so that's our A. And the ratio is just the second term divided by the first term. So minus 1/4 divided by 1 is minus 1/4. And you can pick any two terms. You could have picked that one divided by that one, and you get the same negative 1/4. So our R, that's our A. So our R is negative 1/4. So we're just going to put that and that in the formula and get our answer. So we're just going to get 1 over 1 minus minus 1/4. So minus minus is a plus, so that equals 1 over 5 on 4. So we've got 1 over a number, you can just flip it. Oops, yeah, what you can just flip it upside down, so that equals 4 on 5. That's it. Okay, 11 part E, again, very straightforward. So we're just doing differentiation, and you're going to use the composite rule or the chain rule, whichever one you call it. So for this one, we've got e to the x plus x to the 5. So you're going to move that in front. So I'm going to get 5 e to the x plus x, and you're going to take off 1 to the 4, and then you're going to multiply it by differentiate the inside. So you differentiate the outside, multiply by differentiate the inside. So if we differentiate this, differentiate e to the x, and you get e to the x. Differentiate x, and you get 1. Pretty much that's it. You can simplify it by joining this together, but that is your answer. So if we just make it a little bit simpler, so you're going to get 5 e to the x plus 5 e to the x plus x to the 4. And we're done. Okay, 11F. So this is again differentiation, and this time you're going to use the product rule. So we're going to call this U and that one V. So what you're going to have is either, depending on how you remember it, so V to U plus u to v, or you might write v u dash plus u v dash, whichever way you remember it, doesn't really matter. So what I'm going to do is I'm going to get this one. So my v is log, so I'm going to go log x, differentiate u, so if I differentiate that I get 1, so multiply that by 1, plus u, which is x plus 4, v dash, so if I differentiate log x, you get 1 over x, and then just expand it to make it a bit simpler, so you just get log x plus x times 1 over x is 1 plus 4 over x. And that's it, you're done. Okay, 11g. So this one we've got to integrate again, so it should be straightforward. And on the back of your sheet is this formula. So they give it to you. If you integrate cos, you're going to get sine. And notice this a, whatever value is there, goes in front and underneath. So this 2 will go in front and underneath. So we're going to get 1/2 sine 2x. And we want it in between pi on 4 and 0. So we just put in the pi on 4 first. We get 1/2 sine 2 lots of pi on 4 is just pi on 2 minus 1/2 sine 2 lots of 0 is just 0. And then you can either just put that in your calculator, bearing in mind that is radians, or you can use 90 degrees, or you can figure it out. So if you want to figure it out, you can use your sine curve. So that's 2 pi, that's 1. So there, which is your pi on 2 at 90 degrees, is 1. So this value here is 1. So we get 1/2 multiplied by 1 minus 1/2 multiplied by sine 0, which is 0. So that's nothing. 1/2 multiplied by 1 is just 1/2. And you're done. Okay, we're up to question 11h, which is the last part of question 11. And for this one, you can use your sheet that you're given on the back that tells you 1 over x integrates to log x. So that's sort of a hint to say if you can differentiate the bottom and get the top, it's going to be a log. So if we look at this one, if you differentiate the bottom, you can pretty much get close to the top. So if we look at this, you've got x squared minus 3, and if we differentiate it, that comes in front, we get 2x, and the 3 disappears, which is almost that. So what we're going to do is we're going to put a 2 there and cancel it by putting 1/2 out the front. And now, if we differentiate the bottom, we're going to get the top. All right, differentiate that, we get that, and the 1/2 stays out the front. So that will equal 1/2 log of the bottom. And that's your answer. Since there's no numbers there, you always add plus c, and you're done.